Instead of the familiar green AWS logos, this new Amazon data center cluster in Indiana is built around a different kind of power. Up to 1 million Trainium2 chips. These accelerators are designed in-house by Amazon and reserved mainly for Anthropic, the team behind Claude. A year ago, the site was cornfields. Now it is becoming an $11 billion AI city that will draw as much electricity as more than 1 million homes. The question is simple but sharp. Is this Amazon's secret weapon to escape the Nvidia bottleneck and win the next round of the cloud AI war? Or is it one of the riskiest all-in infrastructure bets of the AI era? We can see the answer in 3 layers. First, how Amazon turned a field into a Nvidia-free AI supercomputer so fast, and what is inside. Second, how that changes the economics of AI, from big enterprise contracts down to the subscription on your card. Third, where this Indiana cluster fits in the web of Microsoft, Google, Oracle, OpenAI, Anthropic, and others, and whether it is a real infrastructure shift or just a new style of AI bubble. Let's land in New Carlisle, Indiana. At the end of 2022, ChatGPT exploded. Every CEO starts asking, where is our AI? At the same time, Amazon quietly looks for a site to build something huge. They do not chase cheap land. They hunt for power and pipes, high voltage lines, big substations, fiber, highway access, and rail. They find all of that on one patch of farmland. By spring 2023, AWS teams will be walking that field. In September 2024, excavators start digging. By October 2025, 7 data center buildings will be online and training models. On a 1,200-acre site, Amazon plans around 30 buildings and roughly 2.2 gigawatts of capacity. It is a massive industrial project built at startup speed. Why move this fast? Because demand for AI compute has gone crazy. From small startups to governments, everyone is begging for capacity. Amazon's answer is to stop being just a GPU customer and become a chip company. Over time, they have built a silicon stack of their own. Nitro for security and virtualization, Graviton for ARM CPUs, Inferentia for inference, Trainium for training. Trainium 1 was the apprentice chip, good enough to ship, not strong enough to lead. Trainium 2 is the first serious punch. Trainium 3, already in design, is where they hope to compete head-on with top-end GPUs. Inside Indiana, Trainium 2 is the workhorse. Each tall server tower holds 64 chips. Hundreds of thousands of these accelerators are stitched into one compute fabric that behaves like a single giant machine. AWS leaders say that when a Trainium 2 is screwed into a rack, a real workload is already waiting, no stacks of idle silicon sitting in the dark. Why would Anthropic bet this heavily on Trainium instead of just saying, send us more Nvidia? First, price performance. Amazon claims Trainium 2 delivers about 40% better performance per dollar than an equivalent GPU instance. Second, availability. If Trainium capacity exists this quarter, while new Nvidia supply is maybe next year, speed to market becomes a huge edge. This is also more than a normal cloud contract. Anthropic is not just renting Trainium, they are helping design what comes next. They tell Amazon how much memory bandwidth they need, how chips should be wired so gradients flow smoothly. That feedback flows straight into Trainium 3. In return, Amazon shows Anthropic how to run at near unprecedented scale, how to stretch a low-latency network across the campus, how to checkpoint models without wasting time and money, how to keep hundreds of thousands of accelerators busy instead of stuck behind a bottleneck. Now, zoom out to the cloud AI war. For a while, the map looked simple. Microsoft plus OpenAI, Google plus Gemini and TPU. Amazon is the giant cloud with no headline AI soulmate. Then Anthropic appeared as an independent lab focused on safety Google invested in and offered TPUs. Amazon invested billions and became Anthropic's primary cloud. Later, Microsoft also started hosting Anthropic models. At the same time, Oracle signed a big compute deal with OpenAI. The one-to-one couples broke down. The new rule is simple. Get the capacity from whoever will give it to you in time. Underneath that sits a hard constraint. Labs like OpenAI and Anthropic cannot just pile chips in a random warehouse and plug in the world's most sensitive data. The enterprise data they need is already locked inside AWS, Azure, and Google Cloud. To bring AI close to that data while staying compliant, you have to push compute into the same cloud where the data lives. That is why capacity in the right place has become the core currency of the AI race. AI demand is strong, but growth is limited by capacity. When demand is this intense, nobody wants to rely on a single cloud, a single chip vendor, or a single country. That is what makes Indiana strategic. It is a huge block of AI compute that does not rely on Nvidia at all. But building it is not cheap. High-end AI data centers can cost tens of billions of dollars per gigawatt. Add up the spending of big clouds, chip makers, and operators, and the world has already committed well over $1 trillion to AI infrastructure. So who pays that bill? In the old internet, the answer was easy. Advertisers paid, and users got free search and social. Generative AI is different. These models are heavy. Serious training burns massive compute. Large-scale inference does too. So almost every AI product today is wrapped in two pricing models: pay-per-use, where you pay per token, per request, or per API call, and subscriptions from monthly pro plans to team and enterprise bundles. Companies sign multi-year AI and cloud contracts. Individual users are nudged into paid tiers that can reach hundreds of dollars a month if AI becomes their daily tool. That is how the cost of Indiana and similar sites is spread. Because of that, investors and cloud providers stare at two key metrics: utilization and token consumption. Are racks and chips actually busy, or just props for a slide deck? Are businesses and users pushing real volumes of prompts, agents, and workflows, or mostly playing at the edges? If both metrics keep rising, these clusters look like the new factories of the digital economy. If they flatten, they start to look like overbuilt malls. Meanwhile, the local cost is concrete. Indiana has granted billions of dollars in tax breaks and support that stretch across decades. Amazon promises around 1,000 long-term jobs and several thousand construction jobs. Residents fear lost farmland, stressed water and wastewater systems, and higher power bills as AI data centers and other heavy industry chase the same megawatts. All of this circles back to the claim, no Nvidia chips needed. Amazon is trying to push the AI race into Phase 2. Phase 1 was about speed in buying Nvidia GPUs and locking up supply. Phase 2 is about building your own stack end-to-end. Custom chips, custom data centers, a full cloud platform. The goal is clear: do not stay chained to someone else's bottleneck. If Trainium 2 and Trainium 3 perform as promised, Amazon gets cheaper training and cheaper inference. It gets tighter integration for anchor customers like Anthropic. It gets a sharp answer when clients ask, what does AWS have that Azure and Google do not? Most importantly, it wins a seat at the table when the world decides where the next generation of AI models will be trained. If Amazon is wrong, the landing will be hard. Tens of billions are locked into chips that cannot compete. Political fights over power, water, and emissions, and the best workloads drifting back to Nvidia, Google TPUs, and AMD. So from the outside, how do you tell whether a mega project like Indiana is genius or reckless? Use a simple 4-question checklist. First, chip. Is the cluster Nvidia GPU heavy, or built mainly on custom silicon such as Trainium or TPU? Second, anchor customer. Is there already a big client running at real scale, like Anthropic, or just promises? Third, business model. Are there solid multi-year enterprise and government contracts, or mostly vague AI-ready talk with no committed spend? Fourth, power and politics. Where does the electricity come from? How clean is it? How will it affect prices and public opinion? If a mega data center can honestly tick all 4 boxes, it is more than a box of servers in a field. It becomes part of a new operating system for the global economy. AI stakes are huge.